In this introductory lecture, we're going to provide an introduction to research and how research is linked with statistical applications in order to answer some fundamental questions. So research can just simply be defined as the systematic investigation into and study of materials and sources in order to establish facts and reach new conclusions. The key operative words in this definition refer to the idea that research will establish facts, and from those facts we can reach conclusions that are agreeable. The whole idea of research is to obtain information and to uncover the truth regarding certain problems and questions of inquiry. Clinical research is an extension of research which is designed to explore connections between facts and theories specific to clinical conditions. And so clinical research just takes the concepts and practices of the research process and applies those processes to understanding clinical conditions in order to improve methods of practice. One way to describe the research process is through what's often referred to as the research trinity, which involves design, measurement, and analysis, which are three subsequent stages that overlap. And the overlapping aspect of the research trinity is critical in order to develop sound research practices. And so when we think about designing research is establishing the quote-unquote integrity of the research, and that refers to the believability of the research process. This establishes what is referred to as internal and external validity. The measurement aspect of the research process is designed around examining what are called constructs, which can also be defined as different concepts identified in a particular research problem. The establishment of operational definitions is going to be a critical component of the measurement stage. The measurement stage also establishes the reliability of measurements. So when we undertake measurements to examine a research problem, we have to have some confidence that those measurements can be counted on and will produce consistent results. Finally, the analysis stage establishes what's referred to as conclusion validity. And that's where we evaluate the information that is gathered at step 2 in the process in terms of measurement. And in this final stage, the research process evaluates hypotheses. And there are 2 hypotheses that will be addressed in this unit and subsequent units, and those research hypotheses include the research hypothesis, which is founded upon the theory and previous findings specific to a research question, and the statistical hypothesis. Research is important, as mentioned earlier, because it uncovers the truth and gets to the heart of the question as to whether claims can be true, or rather valid or not. The poster on the left-hand side suggests that 1 serving of chocolate milk provides the ideal serving of nutrients. However, the advertisement suggests that subliminally that consuming 1 serving of chocolate milk will somehow transform a person into an elite athlete. However, research studies suggest that 1 serving of chocolate milk does not provide the quote-unquote ideal serving of nutrients. However, the advertisement seems to suggest that. The image on the right-hand side is the first page of a research paper published a number of years ago that established a link between the measles, mumps, and rubella vaccine and the development of autism in children. And this research paper generated a great deal of public scrutiny and public concern, and actually influenced the rate at which parents were providing immunizations to their children. The problem with this paper is that the data were fabricated. And so what we see here is that there are numerous stages in the research process where the process can fall apart, and on the left-hand side, the problem with this situation is that the suggestion here may not be entirely true. On the right-hand side, we know that the results were absolutely not true since the numbers were fabricated. In terms of the link between research design and statistics, begins with understanding that statistics really refers to statistical procedures. And when I talk about statistical procedures, we're referring to equations, formulas, calculations that are used to analyze the results of research studies or other information of interest. And this is specific to research studies that collect information in the form of data. And in doing so, those are studies that take an empirical approach. So the empirical approach refers to obtaining information through observation and measurement numerically. And that numerical information produces what's called data, or also scores. So the term data, the term scores are used interchangeably. And so a common question that's asked by many in various fields of study is, why do I have to take statistics? And so statistics is all about understanding information in a valid and accurate way. And so in doing so, the statistical approach allows the examination of problems to separate fact from fiction and address misinformation that may exist in the public or even in the scientific community. To view statistics, it depends on the person that is approaching statistics. And I use the analogy here of a tool, and statistics are often referred to as tools. So in this example here, we see a basic hammer. The engineer would view the hammer from the perspective of designing a better handle to reduce the possibility of overuse injuries. The metallurgist, viewing the hammer, might be interested in selecting a material that would make the head of the hammer sufficient for repeated use. The carpenter, on the other hand, views the hammer as the end user. And when we think about statistics, our view here will be that of the carpenter and the hammer, in that we're not going to be designing equations, we're going to be interpreting equations. And so in the center of the screen, we see a standard statistical equation that's commonly used. And to draw upon the previous comparison, we see that the mathematician would view this equation very differently than the computer engineer. The mathematician may be interested in generating a mathematical proof to establish the truth in the use of this equation. The computer engineer would view this equation from the realm of inputting it into a background code, so that the end user, which are individuals such as those in this lecture, where the practitioner may not be interested in what the mathematician has done, may not be interested in what the computer engineer has used with this equation in developing a code, but wants to gain an understanding of the outcome of research studies to affect actual practice. So this ends our first part of this unit of Introduction to Statistics and Research Design.